Here we have the RacerStar BR2006-2400KV. This was sent in by Banggood for review, so thanks to Banggood for supplying test motors. So we can, us testers can put them through whatever test and share that with you guys. So that's the main purpose, just share the knowledge. Anyway, this is one of their budget motors. I believe these are selling for $5.82 each. You can get the set of 4 for about $21. So that's that's pretty unheard of to get some decent motors for just under $6. And they're not really low grade. They're fairly well made motors, and they perform. And from what I've seen, a lot of people are pretty happy with RacerStar motors that they get. So I took it apart to check out what's inside. So as you can see, the windings are pretty good for this range of price. Nothing wrong with that. It's just your standard winding. Laminations, they seem to be, I don't know if they're quite 0.15 or 0.2. I went ahead and counted the number of laminations, and there's about 30. The best I could count was 30 of those. 6 millimeter divided by 30 gives you about 0.2. So the laminations are 0.2 millimeters, so that's the standard, which is for budget motors, that's pretty much standard. They do say it's Japanese steel, and also they're saying that the bearings are Japanese NMB bearings, and those are your typical size. I believe those are 8 by 4 by 3. So that's a standard bearing size for 3 millimeter shaft. Shaft is the 3 millimeters, and as you can see, the bell is balanced at the factory. There's the balancing epoxy. The magnets are just standard magnets. They seem to be pretty well epoxied in, so I don't expect these magnets to come loose, if you use them on 4S. It seems like most manufacturers have fixed those issues. Before, we used to get a lot of dislodged magnets, and that's becoming rare right now to get those issues. So these come, as I say, these come in a set of 4. You can get them individually. They do come in with rotation thread. So for counterclockwise rotation, the thread is gonna be standard thread. So you tighten it normally. And for the clockwise rotation, it's the reverse thread. So, and they do give you these nice aluminum lug nuts, so that makes it even more of a bargain. Before, we used to get all those either steel lug nuts or those bullet nuts, so that's good. Anyway, as I was saying, the motor's pretty well put together. you know, the bell, the machining is nice, and it has the wire is silicone, and it's about 71 millimeters, 70 millimeters or so. So overall, the motor it doesn't feel like a $6 motor. It feels more like a, you know, a little bit more expensive than that. So that's pretty good. So let's see what the motor weighs. That's with the 70 millimeter wires as it comes from the factory, and that says 25.3 grams. Pretty good weight, I think, for a 2006 size. You know, with the increased height of the stator and the magnets, that's where most of the weight is. It's just about a little bit heavier than a 1806 motor, so this could be a good replacement for 1806 motors. It'll give you definitely more response on you know, on 4 and 5 inch props, so not too bad. So anyway, that's an overview of the motor. So you can see more of the specs on the Banggood product site. I'll have a link on the video description. So as you can see, I actually went ahead and disassemble the bell. It does have a solid solid shaft, and there's a Allen retaining grub screw there for the shaft. Although I don't know that they sell replacement shafts. I mean, they're so they're so cheap. You might as well just buy a couple of spares just to have around in case you end up buggering them. They do use these circlips, which are pretty darn hard to remove. You almost always end up bending them if you don't have the correct tool. That's what they look like, and they use a little bronze washer, a shim. So anyway, that's the overview. Now let's go on to the thrust test, see how the motor does. Alright, so here's the results for the thrust test. The motor performed pretty well, so you can see with I went ahead and tested what I thought would be the more popular props that would match well with this motor. Of course, you could, some people may have other props that they may end up using depending on the application, but I thought this would be the most appropriate for 4S, which is also the most popular voltage in use right now. Of course, other people may want to use 3S, 2S, whatever they want to use, but I just tested 4S for time constraint, and I've been quite busy testing and holidays and all that stuff, so I just wanted to make it simple this time. So anyway, as you can see, one of the more popular props, the 4040 by 3. It's sort of a bullnose prop. We're getting 800 grams at about 20 amps. That's pretty respectable for a 4-inch prop. Also, the motor is actually quite capable of driving, spinning a 4-blade prop. Although the gains are just slightly, they're not that much. You're getting about 60 more grams for about 4 more amps. So this one might be a little bit more responsive. So depends on your the style of flying or what you like. So it's be good to try that 4-blade prop with this motor. Because of the taller stator, what we've been seeing in the test is that the tall stator and smaller diameter motors, they seem to actually have pretty good torque, so they drive more aggressive props. They're able to drive them, and the response of the motor from transition from low RPM to high RPM is actually quite good. So as you can see on the 4045 bullnose prop, that's a pretty heavy prop, the motor is still able to spin it. You get a little bit more thrust, but this is where we can see that it has good torque, because the amps do go high, but they go higher, but they're not a lot higher as you would expect from somewhat overpropping the motor. Usually the amps will climb quite a lot, for not a lot of thrust. But right here we were only seeing them climb a couple of amps, so that's pretty good. The motor, surprisingly, is also able to spin a 5040 by 3 prop. You're getting 1 kilogram, 27 amps, which is not too bad. It is a little bit higher than a bigger motor, of course. Bigger motors will have a little bit more torque, so I think this motor matches well with any of the 4-inch props, and possibly with some of these 5-inch props. You can run them on 4S. Even the 6-inch prop, this is also on 4S. The 6030 is one of the most efficient props, 6-inch props. So you can see you get 1 kilogram and not too bad amps. Again, remember that these numbers here, the thrust and the amps, these are static. So in actual flight, you'll be seeing lower numbers, lower amps and lower thrust. So you gotta keep that in mind. So here I'll talk about comparing the motor to one of the other motors I recently tested. also from RacerStar, the RF2204-2300KV, so that we can get an idea of where this motor falls amongst all the different motors. This being a sort of a new size motor, so it'll be good to see how it where it lands. So this RF2204 is actually from the RacerStar more premium line of motors, so it does use better magnets, so it should have a bit of an advantage in that respect. So anyway, as we see, one of the popular props to use, the 4040x3, the 2006 motor is making 800 grams at about 20, let's say 20.5 amps, versus 791 at 20 amps. So it's practically about the same. That's pretty similar performance. As we move to larger props, meaning more heavier, more aggressive props, like the 4045 BN Dow. The 2204 is making 840 grams of thrust at 25 amps, and the 2006 we're getting 864 at 26 amps. This one's one of the heavy props that actually stresses small motors. A lot of the small motors just start to make a lot of heat, and the amps go quite high, and the thrust just kind of stays there. It doesn't increase. So we can see the motor still making good thrust and pretty respectable. Little bit more amps, but more thrust, so that looks pretty good still. So moving on to 5-inch prop, the 5040x3. This one's I tested an HQ on this one, whereas on the VYS, on the 2204 I used DYS. They're both about the same performance for those two props, so still a fair comparison. So the 2204 is getting 1040 at 25 amps, and the 2006 1071 at 27. The higher thrust is also due to, of course, it's got higher KV, so we expect to get more thrust, but what we're seeing is that we are actually getting more thrust at the higher KV. As I said, when you start to load the motor, what ends up happening is you hit the torque limit of the motor, and you just start making heat. So you'll see the amps climb higher without gaining thrust. So here we see that the motor is still pretty capable of spinning the prop. So that's a good indication of the motor's torque capacity. So that's pretty good. I also went ahead and tested, like I said, a 6-inch prop, but this is a light prop, 60/30. So it's still able to make a little more than a kilogram for a very good 23 amps. So as you can see, the motor is pretty capable. I think it's pretty good performance. It's an interesting size of motor. I think it'll find its place in a lot of applications. I would say it's a pretty good motor to run for 4-inch props. Like if good replacement for the 1806 motors. It's definitely a better performing motor, and weight wise is not much of a difference from an 1806 to this motor. Is probably only a couple of grams heavier, so that's something to consider. It would be a good replacement for 1806 motors, also including 2204s. I'd be interested to see this same motor but with 2700 kV or 2600 kV value. I think that would be maybe or maybe 2500 kV actually. Don't want to go too high on the kV, but anyway, it'd be interesting to see it in higher kV for 4-inch props. It will, it definitely make more thrust, I think. Of course the amps will always go higher, but it would make for an interesting motor for the 4-inch prop quads. So that's the test and review of the motor. I hope you find the information useful, and thanks for watching, and as always, check back soon. I'll be uploading more test results soon. Thanks.